Hi friends, my name is Narasimha and I'm pursuing my BTech at Institute of Aeronautical Engineering College, Dundigal, Hyderabad. So today, as a part of my AIT Tech Talk videos, the subject of embedded systems, I want to explain about a topic named a closer look at IoT's things. Actually, this information has been taken from a research paper. So I want to present that information in an easy way, which will be understandable by all of you guys. So coming to the IoT devices. In our day-to-day life, we come across different types of IoT devices which are seen in our day-to-day life for different types of purposes. So IoT stands for Internet of Things. So for example, if you want to scan any of the QR code and deposit the money, or we have to take the money, so we are scanning the QR code. Means the Internet of Things has been working on the device. So this is a basic example for an IoT device. So we coming to the introduction. In the ever-evolving landscape of technology, the Internet of Things, that is IoT, has emerged as a groundbreaking phenomenon that is reshaping the way we interact with the world around us. As our lives become increasingly intertwined with smart devices and interconnected systems, it's imperative to take a closer look at IoT and explore the intricate web of possibilities it views. This exploration will delve deep into the heart of IoT, unveiling the transformative power it holds and the profound impact it has on various aspects of our daily lives. So, for example, we come across different types of IoT device in our day-to-day life. So nowadays, if you think commonly, no person is being sustainable without having a smartphone, and means up to the not exactly 100%, but some of the percent in our daily life. So many people are using smart devices, smartphones. In the same way, some of the smart devices like smart bins and also different types of devices which have been corrected, which have been transformed the information be it about the QR codes on a linking systems. So this all devices in our life are being increased, which are used for decreasing the distance between the service provider and the user, and also it decreases the latency, is the delay of the process, and also increases the results of the experiments. So this in this way, the technology in our day-to-day life has been used the IoT devices for making the process very simple and easier. Coming to the from smart homes that adapt to our preferences and enhance our comfort to industrial IoT solutions revolutionizing manufacturing and logistics. IoT is revolutionizing industries, societies, and economics alike. It encompasses a vast ecosystem of interconnected devices, sensors, and software, all working harmoniously to collect, analyze, and share data. Through the interconnectedness, IoT has the potential to make our lives more efficient, sustainable, and convenient. For example, in our home, for example, there is an AC or any light system is there, which will be working by claps given by the owner of that house. Means when the owner gives a clap sound, automatically the lights will be on, the fan will be on, or anything the device which has been set before. So in this same way, the device has to store the information and it should be processing the information and it should understand about the information criteria. The feature extraction and feature engineering is being involved in this process. So the IoT devices are making the work easier, and also it is being very convenient, it is giving very convenient and sustainable life to the user or the owner of that device. So coming to this small image, please have a look at it. Sensors. This word is commonly used in all our day-to-day life in many of the situations. So coming to the sensors are electronic devices that measure physical properties like temperature, acceleration, and more. They can vary in terms of origin, ownership, and power source, and the data can have varying levels of integrity. Sensor data can be driven by events or predefined times and may have uncertainty. Sensors can return valid but stale data, and their precision impacts the information provided. Quality and security can vary among sensor types with concerns like tampering, data theft, and calibration issues. Complex sensors can be repaired and data can be encrypted for security. So in our life, we can see many of the sensors like used for measuring the temperature and used for knowing the emotion of a person, and also in different types, used for knowing the psychologistic nature of a person and different sources. So in these sensors, the high level sensors can be repaired and the data can be encrypted and the data storage can be entertained in these sensors. And also whenever the data is theft or any tampering is done, the automatically the recognition and consideration has been observed in the sensors, and it will be very useful for the persons who are being used it for different purposes. So coming to the applications of sensors, there are many applications such as manufacturing, aviation, medical and healthcare, marine and automotive. Coming to the aggregator. An aggregator is a software implementation based on a mathematical function that transforms raw data into intermediate aggregated data. One major use for aggregators is in managing big data. Aggregators have certain intrinsic properties. For example, they might be virtual due to the benefit of changing implementations quickly and increased malleability. Proper care in the aggregation process should be given to significant digits, rounding, averaging, and other arithmetic operations to avoid unnecessary loss of precision. So coming to next one. So this is a clear image which will be a clear understanding about the relationship between the sensors, aggregators, and devices. This is the main sensor, and this all are the devices which have been connected to each of the aggregator, and this all aggregators can be connected to the main sensor. So by which we can see any LAN connection is there, and also it is separately connected to all the PAN means personal area network, and all LAN connections are connected to the wide area network for signal transmission and the information transmission. In the same way, here we can see the arrangement between the sensor, all aggregators, and devices. Let's have a look at it. Next, coming to the communication channel. So even though the sensors, aggregators, and devices are being connected, so how this communication channel means what is the communication channel be used to transform the information from one device to another device? Let's have a look at it. A communication channel is a medium by which data is transmitted, for example, via USB, wireless, wired, or verbal. Communication channels will have a physical or virtual aspect to them, or both protocols and associated implementations provide a virtual dimension. Communication channels can be wireless and could be an offering from the third-party vendor. For example, information is being stored in your mobile phone and it should be transformed to your laptop or any PC. So there are two ways. One of the ways, wired way, that is, you can connect an USB from phone to the laptop and it can transform the information from your mobile phone to the laptop. Another way is wireless, that is Bluetooth, which is familiar word to all of us. So with the help of Bluetooth, we can transform the information from one device to other device. So in the same way, the wired and wireless transmission can be observed as in communication channels. Next, a communication channel moves data between computing, sensing, and actuation. Channel data flow can be unidirectional or bidirectional. Unidirectional is in one way, or in a two ways, it is bidirectional. There are a number of conditions where an aggregator might query more advanced sensors or potentially recalibrate them in some way. For example, to request some more observations per time interval. Come to the decision trigger. So what is the decision trigger function and how it is implemented? Come to the decision trigger function. A decision trigger serves as the final output necessary to fulfill the purpose, specifications, and requirements of a specific network of things. IoT is Internet of Things. Now NOT is Network of Things. It plays a pivotal role in achieving the intended goal of the NOT. That is Network of Things. What is the virtual implementation of decision trigger? Decision triggers often have an corresponding virtual implementation, typically in the form of code or conditional expressions. These implementations define the conditions under which actions are triggered. Abstract purpose definition. Decision triggers abstractly define the ultimate purpose of a NOT. While they may resemble if-then rules, in some cases, not all decision triggers follow this specific format. For example, we have written a code in a Python or Java, anything. For example, simple is if-else case. When a machine wants to take any decision about a condition, so it will consider the if case first of all. If that if condition and the actual condition both are being matched, then it will follow the instructions which are given in the if condition block. Otherwise, it will come to the else case and it will execute the block of the code which has been coded in the else part. So it's not in all the cases, some of the cases. Execution challenges. Failure to execute decision triggers at the intended time, that is TX, can occur due to the various factors. How? These factors may include delays in data collection, issues with sensors, electronic utilities or communication channels, and performance issues with aggregators or other subsystem failures. Not all the time the process is safe and secure. In some of the cases, the execution is not properly obtained. These are the conditions where, by considering which conditions the failure can be occurred in the decision triggers. Impact of bad data. Understanding how erroneous or unreliable data can propagate and affect decision triggers is crucial. Bad data can lead to undesired consequences when decision triggers are based on inaccurate or incomplete information. Coming to the smart grid. Just wait before this smart home or smart country which are being seen in our life. So this is a normal example of using sensors in our day-to-day life, by which the technology being used into the vast conditions and the process has been decreased the delay and gives more results to us. Let's have a look at it. Coming to the conclusion. In conclusion, the widespread use of the term smart is various product categories does not automatically make them part of the Internet of Things. The evolving understanding of IoT raises concerns about potentially diluting its core principles. So thank you, friends. I hope my lecture is useful for you. Thanks for watching. Thank you.